Now, our first presentation today is brought to you by OceanBase Database. Our US audience might not be very familiar with OceanBase yet, but it is actually the distributed SQL database that was used to support China's biggest online shopping event, Double 11. So if you don't know what Double 11 is like and you're in the US, you probably know what an Amazon Prime Day is like. So Double 11 is like Amazon Prime Day, but even bigger. So when I learned OceanBase is open sourced, I thought it would be a great opportunity for all of us to learn about it. I'm very glad that we're able to invite OceanBase CTO, Charlie Yang, to give our community this technical deep dive on the architecture of OpenBase and some typical use cases that he will share. Charlie was here in Silicon Valley just last month when we discussed this, but he had to travel back to China for business purposes. So it's almost midnight there. I am truly appreciate like Charlie staying up to provide audience this live experience. So we're hoping the Wi-Fi connection is well. In case there's any choppy issue, please forgive us. We're trying to do our best. So Charlie, as I mentioned, he's the CTO of OceanBase Database. He has joined Alibaba and Ant Group from 2010. It was the first developer of OceanBase, and he led the architecture evolution and the TPC benchmark test of OceanBase. And now he is leading the development and product team there. So before joining Alibaba and Ant Group, he was a senior distributed system engineer at Baidu, and his research interests including database, distributed system, and cloud. So without further ado, let's hear from Charlie on the architecture overview of OceanBase Database. Take it away, Charlie, and feel free to share your screen.
Okay, thank you, Jasmine, for your introduction. Yeah, but I cannot share the screen.
Okay, let me stop sharing.
You should quit the share. Yeah.
Yeah.
Okay. Now is okay now?
Yep.
Okay, so let's start my tech talk. As Jasmine has mentioned, that I'm Charlie Yang. I'm from OceanBase team. My topic is the architecture overview of OceanBase Database. OceanBase is a distributed circle database starting from 2010, and now it serves all payment requests of Alipay since 2017. In 2019, the peak QPS of OceanBase has reached 61 million on Double 11 Day. As Jasmine has mentioned, Double 11 Day is a very famous shopping festival in China by Alibaba Tmall. It's some kind of like Black Friday or Amazon Prime Day. Besides Alipay and Alibaba, OceanBase is also used by more than 400 customers in mission critical scenarios such as payment, accounting, thief, customer information. OceanBase has set the TPC-C #1 and TPC-H #2 official world record. OceanBase is mainly used in two scenarios, scalable OLTP and HTAP. OceanBase is a Linux scalable distributed SQL database with strong consistency and high availability. So it's very useful in high concurrency scenarios such as Black Friday, launching a new product, and so on. OceanBase can be also used in real-time operation analytics scenarios in one unified system with scalable OLTP. It is compatible to MySQL database with high performance and much lower cost. Alipay, we migrated all MySQL database to OceanBase without any code change of our application, and the storage cost of OceanBase is just for about 1/3 of MySQL database, so the cost is much lower. Let's talk about the design goals. You know, the traditional monolithic database, they have full circle functionality, and the single node performance is very high, such as Oracle, MySQL, SQL Server, and so on. But they do not support some useful features, especially in the cloud environment, such as high scalability, high availability. On the other hand, distributed storage systems such as Bigtable, HBase, Amazon DynamoDB, they support some useful features such as high scalability, high availability, but they do not support full circle functionality. They just support simple key value store API or NoSQL API or limited circle functionality. And yes, there are some distributed circle database such as CockroachDB or TiDB or YugabyDB. They support both high scalability and also full circle functionality. But the single node performance of this kind of distributed circle database are very low compared to MySQL, almost less than 1/3 of MySQL database. In OceanBase, we want high scalability. We want full circle functionality, and we also want high performance of single node. So you can think OceanBase as a distributed circle database with full circle support and high performance of single node. The first scenario of OceanBase is scalable OLTP. The maximum cluster of OceanBase has more than 1,000 servers in our TPC-C benchmark test environment. And in the Alipay production environment, one cluster has almost 6 petabyte data of storage, and one table has more than 320 billions of raw records. OceanBase is linear scalable. It uses Paxos and two-phase commit to achieve high availability and atomic distributed transaction. OceanBase does data shuffle at partition granularity. When we add an OceanBase server, we can migrate some partitions to that server, and so the server can be used very quickly. OceanBase can be also used in real-time operational analytics scenario, as I have mentioned before. After a transaction is finished, OceanBase can do real-time operational analytics immediately. This feature is very useful in some scenarios such as fraud detection, online promotion, and so on. There are two kinds of OLAP workloads. If the OLAP workload is very heavy, OceanBase uses individual replica to do OLAP. As you know, OceanBase uses Paxos to replicate the redo log. So there are at least 3 replicas in OceanBase. We can always use the first 2 replicas to do OLTP business, while the third replica to do the OLAP real-time analytics business. If the OLAP workload is light, OceanBase does OLTP and OLAP in the same replica, and the underlying storage of OceanBase is mixed low columnar storage. By doing like this, the OLAP and OLTP queries can always see the same result. This is the TPC benchmark result of OceanBase. In 2019, we published our TPC-C result that is more than 60 million TPMC and ranked number 1. In 2020, we published a better TPC-C result that is more than 707 million TPMC, and we ranked number 1 again. In 2021, we published our TPC-H result that is more than 15 million QPHH on the 30,000 gigabyte dataset and ranked number 1 at that time. But unfortunately, just after 2 weeks, another database called Paxos published a better result, and then from then we ranked number 2 until now. This is the architecture of OceanBase. In OceanBase, each cluster consists of several zones in one or multiple regions. A region is a city. That is a role called OB proxy. OB proxy is used to route requests to OB server. After receiving the query from the client, the user, OB proxy will pass the query and send the query to the appropriate OceanBase server according to the location info. each OceanBase server, OB server, is very similar to a classical RDBMS. It compares SQL statement to produce a SQL execution plane. There are three kinds of SQL execution planes: local plane, which executed locally; remote plane, which is executed by the remote OceanBase server; and distributed plane, which is executed by multiple OceanBase servers. There is only one OceanBase server. It will be elected to host root service. Root service is used to do global scheduling, global maintenance, and so on. Redo logs are replicated among the zones using Paxos. There are two kinds of transactions in OceanBase. If the transaction is only for one partition, it is executed locally. But if the transaction is for multiple partitions, no matter multiple partitions in one OceanBase server or multiple partitions across multiple OceanBase server, it is executed using two-phase commit to achieve atomic distributed transaction. Let me explain some basic concept to make it more clear. In OceanBase, each cluster has multiple zones. You can think a zone in OceanBase as an availability zone. In most cases, it's just an IDC. And each zone has multiple OceanBase servers. That is a concept called resource pool. Each resource pool in OceanBase has multiple resource units, and each resource unit should be located on the same OceanBase server. OceanBase is a multi-tenant architecture. It divides each cluster into multiple resource pools. You can think a tenant as a standalone MySQL instance in the RDS of the cloud. So each tenant has its own database, and each database has its own table, and each table has its own partition, and each partition can be replicated using Paxos OceanBase. OceanBase does resource isolation internally, not by the virtual machine or by the container at the operating system level. Multi-tenant architecture is very useful to do database consolidation. So the total cost of OceanBase, no matter the hardware cost or the maintenance cost, are very low compared to traditional monolithic database. OceanBase uses Paxos to achieve high availability, as I mentioned before. You know, Paxos is a quorum-based consensus protocol. Each redo log should be replicated to the majority of the replicas. That is 2 out of 3 replicas or 3 out of 5 replicas in Paxos. RPO represents recovery point objective. RTO represents recovery time objective. RPO equals 0, RTO less than 30 seconds. It means that OceanBase can recover in less than 30 seconds without any data loss in case of failure, no matter server failure or IDC failure or total CT failure. OceanBase uses two-phase commit to achieve atomic distributed transaction. The isolation level of OceanBase is snapshot isolation, and we use multi-version concurrency control, MVCC, to make sure that the read queries will not be blocked by the write queries. It's very similar to the traditional monolithic database. OceanBase can achieve linearizability. We use GTS, that is Global Transaction Service, to retrieve the global unique ID for each transaction. You know, in a database, each transaction must have a unique transaction ID. And in a distributed SQL database, the transaction ID should be globally unique. So we use a global service, GTS, to make sure that each transaction has a global unique ID, and so we can achieve linearizability. This is the storage engine of OceanBase. OceanBase uses a LSM-Tree-like storage engine. In an LSM-Tree-like storage engine, we have memory table, access table, and we have two kinds of compactions in OceanBase, minor compaction and major compaction. Minor compaction is used to dump memory table into access table, while major compaction is used to merge several access tables and memory tables into one single access table to reduce the disk size. OceanBase maintains two indexes, B-tree index and hash index automatically in memory table. B-tree index is used as scan, while hash index is used as single row get. The access table in OceanBase is divided into data blocks ordered by primary key. There are two kinds of data blocks, macro block and micro block. Macro block is the unit of write, mostly 2 MB, while micro block is the unit of read, mostly 8 KB to 512 KB, is the encoding and compression unit. OceanBase has two kinds of cache, row cache and block cache used as single row get and scan. This is the circle engine of OceanBase. We have parser, resolver, query transformer, optimizer, code generator, and executor. And we use a system R-like cost-based optimizer to perform query transformation and optimization. If a query is very large, a big query, OceanBase uses vector execution and parallel execution to make sure that it's very fast. We have a component called plain cache. Plain cache is very useful in OLTP scenario. When receiving a circle query, OceanBase tries to match an existing plain in the plain cache, so the parser time will be reduced. This is an overview of several distributed circle databases. From this table, you can see that multi-tenancy is a very useful feature. So it's supported by OceanBase, Google Cloud Spanner, and also CockroachDB. OceanBase and TiDB is compatible to MySQL, while Spanner and CockroachDB is compatible to PostgreSQL. OceanBase supports most SQL features, and the XA stored procedure are supported by OceanBase database, while not supported by the other database. OceanBase and TiDB supports HTAP feature, while Spanner and CockroachDB supports global database. OceanBase and Spanner uses Paxos to achieve high availability, while CockroachDB and TiDB uses Raft. The single node performance of OceanBase is much higher than the other three distributed circle database. It's compatible to MySQL, while the other three databases' single node performance are less than 1/3 of MySQL database. OceanBase and Cloud Spanner are developed using C++, while the other two distributed circle databases are developed using Go and Rust. OceanBase is used in Alipay. It's used by all core business of Alipay, such as trade, payment, account receipt, which represents customer information, promotion, real-time data service. As I have mentioned before, the peak performance of OceanBase is 61 million QPS, and a cluster has more than 200 nodes in our production environment, more than 6 petabyte storage of data. One single table has more than 320 billions of load. OceanBase is resilient to failure in Alipay. In case of failure, it can recover in less than 30 seconds without any data lost. OceanBase is also used by more than 400 customers on mission critical systems. In finance industry, OceanBase is used by debit card, credit card, transaction, billing, accounting systems, and so on, such as ICBC, which is the largest bank of China, and I think is also the largest bank in the world. In telecom companies, OceanBase is used on mission critical boards and CRM systems, such as China Mobile, China Telecom, China Unicom, and so on. In high-tech companies, OceanBase is used in lots of high concurrency scenarios, payment, accounting, customer information system, such as Alipay, Alibaba, Ctrip, Gcash, and so on. Because of the limited time, I will not dig into the technical detail of OceanBase. So if you are interested in OceanBase, you can go to our official website to get more technical detail. And because OceanBase is also an open source database, so you can go to our GitHub project to clone our source code. And this is my email. I also have my Twitter and LinkedIn account. You can talk to me. I'm very glad to answer any question. So thank you.
All right, thank you, Charlie. Very much appreciated. So I did have a question for you. That you mentioned both the hybrid database, the hybrid database can handle both the transactional and analytical workloads. Are there any knobs that you can tune based on the relative importance of the volume of the two?
So you mean that is it configurable, right?
Yeah. It's like,
okay.
How do you configure it?
Yeah. So I have a slide here that I think we cannot have it all, that we cannot get extreme performance on the both OLTP and OLAP workload. So we have a configuration that if the OLAP workload is very heavy, we use individual replica to do OLAP. Then by using this way, maybe the OLTP can be served by low storage, while the OLAP is served by the column storage. So it's different. But if the OLAP workload is light, OceanBase does OLTP and OLAP in the same replicate, and the underlying storage is mixed low columnar storage. By doing like this, although we cannot get the extreme performance, but it's very convenient, and the OLAP queries can always see the same result as the OLTP queries. Yeah.
Let's see. Is there one that you observe that it's more or less on, let's say, when you guys are serving the 11 day, or?
Pardon? I missed your question.
Oh, I mean, like for the volume of those two works, is there one or two that is more often that's tuned towards, or it's not? It depends on the situation. Is it manual?
You mean do we have maybe some tools to tune?
Yeah.
Yeah. It's in OceanBase is a configuration parameter. User can create that tenant, and user he can also configure for that tenant. We have some parameters in database.
So you do, okay.
As, the workload. What about your workload and some other configuration? Got it.
Okay. I did have another question. So how does the hybrid solution compare to like a copy from transactional to analytical database approach?
Yeah, I think hybrid transaction and hybrid workload, hybrid solution, I think for the user's perspective is much convenient, right? But if we want extreme performance, yes, we need to copy that data to have individual copy and use to get the extreme performance.
Got it. Cool. I think that's all the question I have. for the moment. Thank you, Charlie. I really appreciate it. I did post both of the questions on our Slack channel. If I think you mentioned, if you don't mind, just type in the first one. You did mention the parameter. If you do have a link for it, it will be great to just post it on there so that people can, in case they're interested, that they can go for it. All right.
Yeah.
Thank you very much, Charlie. Appreciate it.
Okay, thank
Yeah.
you.